Ma'am, please tell me when to start.
What about the first speaker? She's already on the line?
Yes, yes, sir. She's trying to join. She must have joined also. Sarika? Sarika, our first speaker. Is the issue sorted out?
To join, she is saying that someone denied her entry.
So again, she can
yes,
because it's already 11:30, so we want to start actually.
Just a minute, मैं उसको forward कर रही हूँ invitation again. Hello.
Sarika ma'am, shall we start?
But she has not joined, no? I don't know what problem is there at her side.
You can do one thing. You can do one thing. Madam Nikhil? Madam Nikhil?
Yes, sir.
Sarika ma'am, you can
Yes,
do one thing. If there will be a problem, you can start and you can ask me to start with. I will finish off. In the meantime, you can ask her to join, and then he can be he can take my place because your program will go on.
Sarika, please ask her to join immediately because there are already 101 participants and they have been entered ना 90 बोले थे ना प्रगति आपने उसके बाद YouTube वाले till she joins there I can see 101 participants. How will she join?
Yes, ma'am. I'm also saying same thing. कि we already joined 100 plus participants, so she'll not able to join.
Yes.
Please deny. Yes.
Yeah, that is what I'm telling. You told me we will allow only 90.
Yes.
Rest will join through YouTube.
मैम मैं निकल जाता हूँ नहीं तो
हैं स्टूडेंट्स को बोल
नहीं मैं निकल जाता हूँ मैडम मैं YouTube में चले जाता हूँ
ओके सर थैंक यू सो मच सर एंड वेलकम टू द वेबिनार नाइस टू हैव यू थैंक यू सो मच सर अभी किसी को एंट्री मत करिए अभी फिर से 101 हो गए आपने किसी को ज्वाइन किया है क्या प्रगति फिर से 101 दिखा रहे हैं
मैं नहीं कर रही हूँ ज्वाइन मैं भी वही चेक कर रही हूँ कि जो हमारे कॉलेज के हम उनको यूट्यूब से बोल देते ज्वाइन
हाँ बोल दीजिए स्टूडेंट्स को स्पेशली बोल दीजिए I'll write in the chat box also कि chat box में डालने का लेकिन मतलब नहीं
शाम को भी मिलेंगे वहाँ
एक काम करिए प्रगति please put in the 3 WhatsApp group that the Google Meet is full so participants are requested to join the YouTube. Please put in all the 3 groups. Okay. Sarika, what about our first speaker?
मैम उसको मैंने मेल तो फिर से फॉरवर्ड किया है वो ज्वाइन कर रही है
बट मुझे ये
नहीं करती है तो फिर हम सर से स्टार्ट करेंगे उसको बता देती हूँ मैं वैसे
नहीं 100 पार्टिसिपेंट्स हैं तो फिर 100 पार्टिसिपेंट्स 101 दिख रहे हैं तो वैसे भी नहीं ज्वाइन कर पाएंगे और थोड़े स्टूडेंट्स को बोलना पड़ेगा अपने को
Krisville, you have joined from 2 devices I think so you can leave from 1
हाँ Krisville please because our speaker is not joined yet so actually and अभी
some of you like Aniruddha, Ayushi,
मानसी नेहा जवाड़े बेटा हमारी स्पीकर नहीं ज्वाइन हो पा रही हैं क्योंकि पार्टिसिपेंट्स ज्यादा हो गए हैं 100 होते हैं प्लीज आप यूट्यूब से ज्वाइन कर लीजिए मानसी हाँ ओके, मानसी इज लीविंग. 99 हो गए, आप किसी को एडमिट मत करिए. प्रगति आई थिंक दैट विल बी फाइन. 99 है अभी, तो मैम के लिए छूट भी है. हाँ अभी किसी को एडमिट मत करिए, डिनाई कर दीजिए. तीनों ग्रुप्स में डाल दिया आपने?
हाँ मैम मैं वही कर रही हूँ.
फिर से 101 दिख रहे हैं, लेकिन मुझे
किसी को भी ऐड मत करिए.
ऐड क्यों हो रहे हैं लोग ऐसे, जब तक ये अलाउ नहीं करे?
कॉलेज आईडी से हो रहा है ना, वो ऐड हो रहे होंगे.
ओके
स्टूडेंट्स है हमारे.
नहीं तो आप ना फिर कैसे करेंगे? फिर
हमें रिमूव करना पड़ेगा.
तो लेकिन वो स्पीकर तो बताए ना क्या है फर्स्ट वाला, वो एक बार ज्वाइन कर ले तो फिर इशू नहीं है.
Ma'am, why don't we start with?
She has joined. Hello, ma'am. Hello, welcome. Ma'am has joined, so we can start now. Okay. Ma'am has joined.
Reeta has joined, no? Okay.
Pragati, you have put in the chat box that please join through YouTube. Google Meet is full.
Yes, ma'am, in the group.
Good morning, Dr. Reeta. Welcome to the webinar. Good to have you.
Ma'am, shall we start?
Yes, sure, Kavita.
We can start now.
Yes, sir. We are starting.
Then share the so that next can also come in the recording.
With truth and love, our college credit call. Come be a strong and youthful man. For God and country, freely pledge we all, led by the flag for which we stand. Blue for the mind that seeks the good and true, red for our promise in the game. White for the glory of a heart that's pure, bright with an ever-shining flame. Alma Mater, we hail, God give us and great success. With truth and love, we'll conquer all, for God, our land, and SFS. Alma Mater, we hail, God give us and great success. With truth and love, we'll conquer all, for God, our land, and SFS. With truth and love, let us unite and be to our glorious college name. High on the hill, a beacon light is she, leading our children on to faith. March on to glory is a message bold, spread truth and love will far and wide. Lauded to the excellence of guidance school, teacher and pupil side by side. Alma Mater, we hail, God give us and great success. With truth and love, we'll conquer all, for God, our land, and SFS. Alma Mater, we hail, God give us and great success. With truth and love, we'll conquer all, for God, our land, and SFS.
A very good morning to you all. I, Dr. Sarika Gurau, Assistant Professor, Department of Botany, St. Francis de Sales College, Nagpur, extend a warm welcome on behalf of the management and Principal Sir Dr. Katie Thomas for this one-day international webinar on steps towards environmental sustainability. SFS College is located in a serene environment of Seminary Hills. It is a Christian minority institution established in 1956 and is managed by Archdiocese of Nagpur. It is accredited A grade by NAC Bangalore with a CGPA score of 3.23. SFS College works with a mission to create and facilitate an environment for knowledge, research, skills, self-reliance, and humanitarianism that propels the young minds to build a caring and sharing society. Now, I would like to welcome Dr. Nikhat Naqvi, Head of the Department, Botany, for welcome address. Over to you, ma'am.
Thank you, Sarika. Good morning, everyone. I, Dr. Nikhat Naqvi, Head of the Botany Department, welcome you all on behalf of Principal and Management to this international webinar on steps towards environmental sustainability organized by Botany Department, St. Francis de Sales College, Nagpur. The practice of environment sustainability helps to ensure that needs of today's population are met without compromising the ability of the future generations to meet their needs. When nature is left alone, it has tremendous ability to rejuvenate itself. However, when man enters the picture and uses the natural resources provided by the environment, things change. We all have seen this during the pandemic and the lockdown period. Achieving sustainability will improve the quality of human life and also long-term environment quality. However, moving towards sustainability can involve many challenges. As individuals, we can take small but effective steps towards more sustainable lifestyle, like switching to reusable products, practice the R's, reduce, reuse, recycle, and we can implement and practice many more R's like refuse, regenerate, replenish, rejuvenate in our day-to-day life. Reduce our dependence on single-use plastics, use environment-friendly products and technologies. Then the concept of green buildings, which is coming up, it's an important step towards environment sustainability, where we are using eco-friendly construction material, eco-friendly bricks, and construction of roads from the paper waste. All these innovative ideas, I am very happy to see on the net that they are being implemented by our youngsters. So our youngsters and our young students, they are very important stakeholders in the steps, goal of the steps towards environment sustainability. Then use of carpools, then judicious use of water resources, especially at your homes, your offices, your place of work. And all these in turn will reduce our global carbon footprint, and it will also encourage individuals to live in a way that creates minimal waste and regenerate some of the resources we use every day. Green audit, energy audit, use of sustainable, clean and green energy. They are all the steps taken to achieve sustainability. And my dear participants, let me add on one more thing, that you don't need to have a degree in environmental science, formal degree in life sciences to achieve this goal of environment sustainability. Just a small efforts, small steps as an environment conscious citizens will go a long way in achieving our goal of environmental sustainability. And I am confident that this webinar will bring significant changes in our mindset, especially our young students, in taking small but significant steps towards sustainable living. To share their vast experience and knowledge, we have two guest speakers from two different corners of the globe on this digital platform. Our eminent speaker of the first session will talk about biofuels, which is an important component in achieving our goal of environmental sustainability. The speaker of the second session will share his vast experience on conservation of biodiversity with special reference to animal biodiversity. I know our participants are waiting eagerly for the technical sessions. So without any delay, I hand over the proceedings to Dr. Sarika.
Thank you very much, ma'am, for nice words and giving few tips for moving towards environmental sustainability. Thank you once again. Dear participants, our speaker for the first session, Dr. Reeta Rani Singhania, is a research associate professor at National Kaohsiung University of Science and Technology in Taiwan. She has worked at CSIR National Institute of Interdisciplinary Science and Technology, Trivandrum. She has worked as postdoctoral fellow at Université Blaise Pascal, Clermont-Ferrand, France, and at DBT IOC Center for Advanced Bioenergy Research, Faridabad. She has also worked at Center of Energy and Environmental Sustainability, India, as a chief scientist. Her key research areas are microbial and enzyme technology and bioprocess technology, production of biofuels from lignocellulosic biomass. She has 9 patents to her credit. She has edited 3 books and published more than 120 research articles, book chapters, and conference communications. She is recipient of various awards like BRSI Women Scientist Award, IFI BIOP Young Scientist Award, AUCBT Excellence Award of BRSI, Elsewhere Best Paper Award, and Most Cited Award from Elsewhere. She has also received DBT Bioscience Energy Overseas Fellowship. And besides that, she has also served as guest editor of various international journals for special issues and is an editorial board member of Bioresearch Technology, Biofuel Research Journal, and Journal of Energy and Environmental Sustainability. She is also an editor of Bioresource Technology Reports and associate editor of Helion Energy. And she has got many patents and various research papers to her credit. Now, I would like to invite Dr. Reeta to enlighten us on the topic bioethanol production from biomass via enzymatic route, a sustainable approach. But before we begin with the session, a kind note for the participants. Please post your questions if you have any in Google Meet chat box or YouTube live chat. And those who have joined through the Google Meet are requested to keep their microphones off.
Oh, that's
Over to you, ma'am.
Thank you so much, Sarika, for wonderful address. And thank you so much, Professor Naqvi, for your warm welcome. So, I would be speaking about bioethanol. Mainly, I have prepared my presentation so that students can get some messages like biorefinery, what is biorefinery, and how we can, how following the biorefinery we can, we can make a difference in the environment and how it helps in bringing a sustainability to the environment. So I will share my presentation here. It's coming, it's not coming. Okay, let me again try. It's not. Yeah. Yeah, so I hope everyone can see my slides.
Yes, it is visible.
Yeah, thank you so much. Okay, so I'll be speaking today. I'll be talking on bioethanol production from biomass via enzymatic route, which is a sustainable approach. So this is just because I'm working here at NKUST, National Kaohsiung University of Science and Technology, as Sarika has already said. And this is NKUST first campus where I'm working, because we have 5 different campuses in Taiwan at Kaohsiung. And this is some few glimpse of the university where I work. So I thought I will start this talk for the students, like what is refinery and what is biorefinery. We keep on listening everywhere, like biorefinery, biocirculation, circular economy, and something. So we should know all these concepts when it comes to our ears. So what is the difference between petrorefinery and biorefinery? Why the society today is moving towards biorefinery from petrorefinery? So we know that in petrorefinery, if we speak about petrorefinery, it is nothing but when the raw material is the crude oil or the natural gas, and then we get number of products which are obtained from there, like different products like light oil, kerosene, naphtha, and gasoline. So these all products are obtained from the crude oil to make the process economic, and that is called as petrorefinery. So why we are moving towards biorefinery in this at the present time? So we have to know what is biorefinery. It is like where we are using biomass instead of crude oil and instead of natural gas. We are using biomass for getting the number of cascades of the products, so which is called as biorefinery. So here, like, we can use this biomass, which is the most abundant available resource available for mankind to be used for the benefit. So we can use this biomass to produce a number of products where by various means, like there are different routes for production. And here, like gasification, then saccharification, extraction, these are different steps. Like when we do gasification, it is directly converted into gas, which can be used as fuels. So here, why we are switching to biomass when we have this crude oil with us, we have to move. Why? Because we need a sustainable solution for each and every problems. Like if we are using something which is obtained from biomass, we know that biomass is the most ubiquitous raw material. It is going to sustain in the environment, in this planet, till the life will exist. So it's not going to finish at any point of time, right? So these crude oil, these petroleum products are going to get depleted. These fossil fuels resources are getting depleted. We keep on hearing this. Maybe it is available for maybe 50 more years, but then we have to have technology, something which is sustainable and is going to end till the planet remains. So that is why we are moving towards biorefinery, where biomass can be used as raw materials and we can get a number of products to make the process economic. So here we will see few things on this. Like what is biorefinery? As I said, it can be processed or refined. When biomass can be processed or refined to obtain multiple valuable products, then it is called as biorefinery. And it leads to sustainable co-production of like cascades of products like food, feed, energy, fuel, and chemicals on an economically sound basis, and is also definitely eco-friendly manner with minimal generation of waste. We try to make technologies in today's date, which are zero waste technologies. That is very important from when we talk about environment point of view. So environment is the most important thing today, which we have to concentrate on. So yeah, here we can use this biomass, and then separation technology and catalytic conversion can be used to convert it via biorefinery process into fuels, which contains ethanol, biodiesel, and solvents like acetone, butanol, tetrahydrofuran, bulk chemicals, succinic acid, sucrose, plastics, maybe thermoplastic, starch, and PHB, PHA, what all we can get from this. And then fibers like cellulosic fibers, fine chemicals, lactide esters, And then oils like corn oil or triglyceride also we can obtain. So these are like number of products. As we obtain products from petroleum, crude oil, different products we get like petrol, diesel, naphthalene, and then all these things. So in that way, we are getting these different products from biomass also. So we can like check on what all we need due to the, to see how the process can become economical. So when we talk about like circular biorefinery approach, this is just an example. Like when we use algae as a biomass, algae is also a biomass, right? Algae is a kind of microorganisms. Nowadays, this algae are like on the top of the sky. Everyone talks about algae because it is coming up as the most sustainable resource to be utilized for different value addition. So here algae are green cells, just like plant biomass. This also utilize sun energy and carbon dioxide for their growth, for their production. So these can be used as a source of oil. Oil can be extracted from it, and then we can have protein. After extracting the oil, whatever is left can be used for extracting protein, and this oil can be converted into biodiesel. While this process is happening, like when biodiesel is produced, then we get byproduct, which is glycerol. And that is why we are talking about, like these days, we are trying to use glycerol as a carbon source for most of our bioprocess, like what I work on. So we are trying to use glycerol as a bioprocess for different kinds of productions, like if we can convert this glycerol to maybe bacterial cellulose or something which is very important, high priced product. Sorry, it can be used, and then we can make this process more economical because we are getting some byproduct and then we are adding value to it. So that is something very important. We have to think, like whatever technologies and processes we are developing today, we have to take care that each and everything which is coming out of the process can be utilized for the benefit, and it can add value, and it does not harm environment in any way. So then this biodiesel can be used as biofuel, and then when vehicles are run on it, carbon dioxide is released. Though the carbon dioxide which is released is comparatively far lower than what is released from the petroleum car or diesel car rather than biodiesel. So these carbon dioxide, when it is released, it can be again used by the algae for the production of biomass. So that is how we can say that this process is circular, because whatever is coming out of it is again going to the chain. So yeah, but however, algae is not my focus. I just said as an example that we should know what is the circular bioprocess also. So here I'll be talking more about lignocellulosic ethanol, like how plant biomass can be converted into ethanol. So there are several important things which we should know before knowing the process, like what is actually the plant biomass. If we see the plant which is erected on the land, so we have to know that this plant biomass, what are all the components which it contains. So this is the plant cell wall, and it contains different three major components are there. There are some other things also, but then the three major components are like cellulose, then hemicellulose, and then the lignin. Okay, so cellulose, hemicellulose, and lignin are the most important components which is present in the biomass. And to convert it into ethanol, our interest goes on cellulose and hemicellulose also. So cellulose is, what is cellulose? Cellulose is nothing but the chain of glucose. Glucose monomers are linked to each other by beta-1,4 linkage, and this is like very highly polymeric. It contains more than 5,000 units to make cellulose fibers. So this is like, and what is hemicellulose? This contains pentoses, xylose linked with each other, and then lignin are aromatic compounds. So this is like linked together with hemicellulose, and these linkages are very intricate. This is the presence of lignin is the reason for the recalcitrance of the biomass to be attacked by the microorganisms. As we know that plants and trees are there in the planet and how they are resistant to the microbial attacks. We know that if something is dead, like plant lies in the plant matters or something lies in the soil, then it gets degraded. But how the plants, when they are surviving, they are erected and they are well protected. So nature has made it such a way that it contains lignin which protects them from the microbial attack. And this is a boon for them, for the plants. But now when we human beings, we want to degrade it for the benefit of ours, that we want to we want to extract glucose out of this waste biomass, then it is a difficulty. Why? Because nature has made it in such a way that it contains lignin and it is very much resistant to the microbial attack. So for getting glucose out of this biomass, we have to remove lignin. Maybe not completely, but we have to remove so that the enzymes that we are going to use to hydrolyze cellulose or hemicellulose can easily access these components of the biomass and can get hydrolyzed to give us glucose monomers. So yeah, here we will see that how do we go from biomass, from plant biomass to ethanol. How do we go here like this? Now, one thing is like, what is ethanol and what is bioethanol? So chemically, there is no difference in both of these. Ethanol, whatever we get from glucose syrup or sugar solution is the ethanol. And when we talk about bioethanol, it is normally it is used to reflect that it is produced from the biomass. But chemically, there is no difference. So here, like, see, we can get this ethanol from sugars by doing fermentation. Sugars, when just we put the baker's yeast into it, sugar solution, then it will be converted into ethanol. You can see the smell of the ethanol in that. This can be tried in our kitchen itself, okay? So, and if we have starch, which is called as first generation ethanol, like we can convert starch also by hydrolysis into ethanol. There is no difference. But when we are using cellulosic biomass, plant biomass, then we have to do pretreatment, then we have to do hydrolysis and then fermentation, and then it produces bioethanol. It is called as second generation ethanol. Why? Because it is produced from cellulosic biomass. And now it's not that we can use any cellulosic biomass. Like we have crops in our farms. We cannot use anything which is competing with the food. Okay, so like starch is very good feedstock to be converted into ethanol. Sugar syrup is very good feedstock. It has nothing to do like just we can get sugar syrup from the sugar cans and then we can get it fermented into ethanol and the job is done. But then no, because these are competing with the food. And we cannot make it easy to be used for the biofuels. So here we are targeting cellulosic matter. And this cellulosic matter, whatever is available in surplus, that means if it does not have any alternative applications which is more important than bioethanol, then only it can be used for bioethanol. So here like we have several steps which needs to be followed. First, it is pretreatment. We have to do pretreatment for the lignocellulosic biomass. We cannot just get it from the farm and can put enzymes into it and then get it done. No, it's not possible. First, we have to do physical pretreatment. That is, we have to grind it into small particles, and then we have to do pretreatment so that lignin is removed, or otherwise also the cellulose and hemicellulose becomes more amorphous, so that when we add enzymes there, they can attack on the cellulosic fibers to do hydrolysis, and we can get glucose, which is then converted into ethanol by the yeast. The process is called as fermentation. Here we get ethanol, and then it is being distilled into purified, whatever purification we need for us. Okay. So yeah, I thought just give a brief idea about what is the global biofuel market today. So here, like when we see by region, then North America is definitely it's like it is dominating the whole market, followed by Europe, and definitely by then after that India comes like Asia Pacific region as well as the rest of the world. And when we see market by type of the biofuel, then we know that we can see from here that cellulosic ethanol is having the highest share, more than 20% by 2017. However, it is predicted to be decreased after 10 years. Like in 2026, after 5 years, we can expect little decrease in this. Okay, and then biogas. Biogas is showing increasing trend. Like after 5 years, it will have better market, definitely. So if we see the market by the feedstock, then also lignocellulosic biomass is highest. It is going to increase after 5 years. Then algae, if we see, it is very high. It is highest in today's date, and then it is showing little bit decrease in after 5 years. So these are just the trends, like these are predictions. It may be completely true or it may be a little bit, there could be some deviations, but then usually these are made on very strong study and it is true. So these are the top companies. If we talk about global biofuels and biodiesel like DuPont, Grand Bio, Ethanol, POIC, DSM, Advanced Biofuels, and Renewable Energy Group. So these are some of the market players in the field of biofuel. Yeah, here also I have listed some companies and their site in the sense which country it is situated, it is constructed, and also the feedstock, what it is operating with, and then the year when it was constructed or situated, and then what is the like million liters per year, how much it is producing the biodiesel or biofuels, and then the type, like it is by demo plant or industrial plant or commercialized plant, and the status, whether it is idle or still it is operating or it is under construction or something like that. So for example, if we see maybe DuPont, then it is based in USA and it is using agricultural residue. It was constructed in 2016 and it produces 140 million liters per year. And this is the first industrialized plant and is idle now. That means it is not operating now. So there could be different reasons for it. There are bankruptcy, there are technological challenges. Some of them have revealed what was the challenge and some of them have not revealed. Now the Borregaard is very important, one of the important company which is in Norway, and it's using woody biomass for bioethanol production. It was commenced in 2013 and then producing only 0.14 million liter per year and was the demo plant and is still under operation. And now Borregaard is coming with several big industrialized plant. Why? Because they are targeting lignin also in the biorefinery, like not only cellulosic and hemicellulosic part, but then lignin also. Lignin is very important. It can add a lot of value to the whole process. So they are targeting that, and that is how it is reflected that their process could be more economic than others. So if we know in the international market, only Praj is there, which has some name that it is recognized in the international market from India. So they are also using enzymatic route to convert or we can say biochemical conversion route to convert lignocellulosic biomass into ethanol. Here there are various processes. As I said, it could be like by gasification that this biomass can be directly converted into gas. Then biomethane can be produced from the biomass, and then high efficiency power generation also by gasification, and then intermediate bioenergy carriers can be produced through thermochemical processes. So thermochemical process, gasification process are there, and then biochemical and chemical conversion processes are there, which is of our interest because we are looking for something which is more sustainable. So here, this lignocellulosic feedstock, this can be converted into sugar by using the enzymes, and then it can be converted into ethanol by fermentation. So here I would discuss about second generation bioethanol. Yeah, this was introduction about like what I'm going to talk about. So I have worked for 5 to 6 years in Indian Oil Corporation Limited, their bioenergy center. So there we were given a goal like we have to have. So research can be started in a two-way, I believe. First is like you can start with like something you have got and you do not know how to do it, but then you start with a passion and you can go on. That is possible. And sometimes you are given a you have given a fast track project. So there what we have to do is we have to set our goals first, and then we have to make a roadmap to go ahead on that. So it was like we were having 5 to 10 years to come up with the technology for bioethanol production in Indian Oil Corporation. And then what we decided was we have to get 4 to 5% ethanol in the fermented broth. And for that, for getting this much sugars, for getting this much amount of ethanol, we should have 9 to 11% of sugar in the fermentation broth. That means you must be knowing that how this ethanol is converted. Like 0.51% is getting converted into ethanol and 0.49% is metabolism, or maybe other way around. So it's like 50% of the sugars can be converted into ethanol, not more than that. More than that. This is the theoretical maximum efficiency, which is not always possible. So, but then we can reach to more than 98% also, because conversion of sugars into ethanol is not a big deal. It's like very well placed technology and it can be done. The challenge lies in producing sugars. After sugar to ethanol is not very difficult because there are very potent yeast available with us and we can easily convert it. So we have to have 9 to 10% of sugars to get this much of ethanol. So we have to go through enzymatic route. We need to do saccharification. So how it will be reached? Like we have to obtain 75% of hydrolysis, and by using less than 10 FPU to make the process economic. And for this, we need solid loading. How much? 20 to 25%. Because we know that in a biomass, how much is the cellulose? In biomass, maybe we can have 50% of cellulose maximum, of 40 to 50%. So if it is 50% also, if you are taking 10 kgs of the biomass, then we can have only 5 kg of the cellulose. And 5 kg, if we are able to convert maybe 4 kg into glucose, then how much glucose will we get? It is calculated in that way. Okay, so what we had to do is like 20 to 25% total solid loading we have to load, and this is very high. If you don't feel like 20% sugar or 20% salt solution is very easy, but when you are going to put 20 to 25% of your pre-treated biomass or treated biomass, it's really difficult. It makes like it is more, it doesn't even reach the paste type of thing. It is very solid. So that type, in that situation, for the enzymes to act is really difficult. But then it works, definitely. So for that, what we can do is we can increase the cellulose amount in the biomass. As I said, 50 to 60% maximum we are getting, but we have to increase it to 70%. So how we can do it? We can do it through pretreatment. How? If we are able to remove the other undesirable components from the biomass, like little bit of lignin, maybe the extractives, maybe the other things, then we can increase the amount of cellulose in that biomass. So here, 50 to 60% is the hollow cellulose in the biomass, and it will result in reducing the total solid loading if we can increase it to 70%. And it will also reduce the equipment sizing. So that means that the process will turn to be more and more economical. So here, if you see, it is just an example. Like I have taken rice straw as a model substrate. Here you have 37% of glucan, that means cellulosic portion, and then 23.5% of xylence, and then lignin, ash, and acetic acid is there. Extractive is very high. Extractive means all the waxes on the top of the biomass, whatever is available, that is extractive. And these extractives can be easily removed. So what is our interest is this, which is 60%. We have to increase it to 70%. So we can remove maybe these things. We can target few of these things and we can remove it to increase this portion. And that is what we did through pretreatment. So removal of unwanted material can pave the way to increase the carbohydrate. Now, as I said, we are converting this biomass into ethanol following the enzymatic route. So here comes in picture the cellulases and what was the rationale and significance behind working on cellulase. Like my major contribution was towards cellulase only. We have developed a bioprocess for cellulase production, and cellulase is a major cost component in the whole bioethanol process, and cellulase is not a simple enzyme. It is a complex enzyme system which contains many different components. And you can see here, it contains beta-glucosidase, cellobiohydrolase, then endoglucanase, then LPMOs are also in the picture. So this, if we see this is hexoses, that is glucose linked with each other, and this you can maybe imagine as a cellulosic fiber. And here, cellobiohydrolase attacks first, and then cellulose binding module sits on the make a place, and then it hydrolyzes, giving reducing and non-reducing ends. And then BGL acts on it to produce glucoses. Okay, so here endoglucanase also. First of all, endoglucanase acts, and then cellobiohydrolase acts, and then beta-glucosidase. And LPMOs are producing NICs here at the reducing and non-reducing ends. So these all enzymes act in a very synergistic manner to hydrolyze the whole celluloses into single units, that is glucose, which is of our interest. So these also require accessory enzymes like xylanase is there, lactase is there. Sometimes if those are also there, it makes the process more easy. Even the pectin, because biomass contains these things also, and that if that can be removed, then these enzymes can act easily on the celluloses, which becomes amorphous, is easily accessible to these enzymes, and then can be easily hydrolyzed into glucose. So here the single microorganism, if we are planning to use for producing all these components, it's quite difficult, right? But there are several fungi are known to produce cellulase, which contains maximum of these components and can produce glucoses from the cellulose. Sorry. But then here, it's difficult to get every component in an efficient amount. So what we can do is we can either go for producing cocktail, like we can mix some component is being produced from different fungi, and some component is being produced from different fungi. Then we can mix both of them together. But we have to take care that there is synergy among the enzymes. Otherwise, it will be useless, right? So we have to find several strategies. We will be talking about that. And then fungi are the most studied microorganism for cellulase production, though bacteria are also known to produce cellulase. Okay, so strain improvement is very, very necessary if we want to produce high titers of cellulase in an economical, feasible manner. And then on-site cellulase scale-up is very necessary for biofuel production, so that we can utilize the same biomass which we are going to hydrolyze as a source of cellulase production, also as a substrate for the production of cellulase. So here, the major objective what we had was to produce cellulase in a cost-effective manner, because producing cellulase was not a big challenge, but then it should be produced in such a way that it is economically feasible, like we can use like maybe few thousand per liter, and also because the end product is not very costly thing, right? If we are going to produce something which is the end product and is very costly product, like we can sell it for 2000 liters, 2000 rupees per liter and this, that, then it is okay. But then we are targeting bioethanol, which is not very costly. You can maximum sell it at the price of what what petrol is being sold. So that is, we have to take care, and for that we have to have a cost-effective process. So we have tried several multifaceted approach for reducing the cost. Like we have used pre-treated biomass, then we have tried to use cheaper nitrogen source, avoiding downstream processing so that we don't need to purify the enzymes actually. And then we can do strain improvement so that the total overall cost can be reduced, because we can convert our fungi to be a hyper producer of cellulose, which produces very high quantity of cellulase, and then it can be used for hydrolysis of the biomass. So here, this picture shows like this is an integrated process where when we say on-site, that means where we are converting this hydrolyzed sugars into ethanol. Ethanol plant is there, and the same place we are having cellulase production plant. And when we talk about integrated project, yes, it is the same thing. We have to have cellulase production in the same installation where we have this ethanol production, so that we can use the same pre-treated biomass as a source of production for cellulase, and then it can be of the same biomass. So every now and then we always listen that why do we need to produce cellulase? Because we have novozymes, we have Janencore, which are very renowned for producing cellulase, and that too for biofuel applications. So it is like in India, we are facing challenge. This Novozyme are Denmark-based company. We have a company, Novozyme, also in India also, which is producing cellulase for biofuel. But then other companies which are there, like Advanced Enzyme Technologies, this is also producing cellulase, and Omgene Biosciences, and few small companies like Nourzymes also. But then these cellulases are not specific for biofuel application. That is, they are not meant to hydrolyze biomass. They are maybe they are based on special applications in detergent or some fabrics. So there are different applications of cellulases. So they are based on that, and we can use them for biomass hydrolysis also. But then they have to be very specific. So that is why we have to be like self-reliant. To be self-reliant, we should have our own technology. Like we are buying from Novozymes, we are buying from Janencore, but at the end, if they are going to increase the price just because we are not getting it, so we should have our own technology also in hand so that our plant does not get shut down, right? So we know that these cellulases are sustainable supply of cellulase is questionable, because proprietary to few selected companies, as I said, it is just produced by few selected companies, and these are developed on feedstock, single feedstock, if at all available, like Novozyme. These are available on, like they have been tested well in the corn crop. So if we need to have our, in India, we need to have multi-feed technology. We cannot use corn cob, definitely we don't have. But then if we are going to use rice straw in one season, maybe we need to use wheat straw in another season, and then we need sometimes sugarcane bagasse, and sometimes we can use cotton stalk. So we have to have a multi-feed technology, and for that we need specific enzymes for all these biomass, or a enzyme which can act on all these biomass, a versatile enzyme. So that is, our need is different from what is needed by the US or by European companies. So that is why, and also it is like these all companies are not, they are not selling. If you see that these enzymes are being produced, it is available in the market, but if you go to buy a lot, then it is it is not very cost effective. And then these companies are selling products, not just like you can buy a few tons from them. They want you to have their technology. They want to sell their technology, set a plant with your ethanol plant, and then it is a normal practice like Didec, Novozyme, Genencore. See, DuPont has taken Genencore into it. Why? Because Genencore produces enzyme and they become partner. So it's not now if we want to buy Genencore's enzyme, it's difficult. So those things are there. And then we were working in our lab to have bioprocess technology on a large scale, to scale it up, that technology. And we were facing a lot of difficulties, like small scale studies are available on cellulase production, but then the large scale challenges were not mentioned in most of the research articles, which we faced so many. So cost impact of individual steps, if we see, as I said, that the cellulase enzyme cost about 15 to 20%, and then pretreatment step also causes a lot of So here, multifaceted approach has been adopted worldwide, not only in our lab, but everywhere. It is like when we see configuration of cellulase production, it could be integrated, as I said, integrated or on-site or off-site. Off-site is like we can buy enzyme from anywhere, from different company, or it is being installed in some other city and you are just getting enzyme from there and using for your biomass, where you have ethanol facility. On-site means you have in the same place your cellulase production facility also with the bioethanol facility. Integrated, when we say, that means that we are using it is very near, it is associated, it's not two different units, but together, where we are using the same substrate, that is the pre-treated substrate for the production of cellulase, and the same thing is being hydrolyzed by the cellulases for ethanol production. And when we say consolidated bioprocessing, then it is in the one reactor. Like we have to have one microorganism which can produce cellulase, which can produce ethanol also. So it will produce cellulase, hydrolyze the biomass, and in the meanwhile, it will also keep on converting it to ethanol. This process is very interesting. However, the efficiency is quite low. So that is like, there are some reports that it is also now being, maybe few researchers are having really efficient microorganism for that it has not been industrialized till now. So we have to select a type of bioprocess, like fermentation process, which is solid state fermentation, submerged fermentation, fat batch. We have to see which one is most suitable for our cellulase production for the particular kind of microorganisms. So we have to select fungi also, that is microorganism. Trichoderma is the most potent fungal source, which has been exploited very well. And then penicillium is now running towards like competing hard with Trichoderma because it is also known to produce all the components of the cellulase, and that too in an efficient manner. Humic E. coli is also known, Talaromyces and Melannomyces. These are the forerunners in fungi for cellulase production. So then we have to select the crude agricultural residues, which we can use. It will be a cheaper carbon source. If we compare it from Avicel or from glucose, then definitely it is cheaper, and we can select any one of these based on our process, our microorganism, which is being able to utilize these. And then also we can target strain improvement by mutation or CRISPR-Cas9 process, rational engineering, genetic modification, so that these fungi can produce high titers of cellulase. And then complete repertoire of cellulase is very difficult to obtain from single microorganism. So in case if we are not able to get it, maybe we can target two different microorganisms, can produce separately, and then can prepare a cocktail. Or we can engineer them, like in Trichoderma ricci, it can use as a host, and the enzyme which is being produced by Trichoderma ricci can be used as a base enzyme and can clone maybe Aspergillus or Penicillium's BGL gene into it, so that the BGL which is less in that deficient, Trichoderma ricci is a little deficient in BGL, it can be supplemented. So these strategies have been followed worldwide, and few of these have been done by us also to reduce the cost. So this is like in our lab, what we did, strain improvement, we followed mutagenesis and we screened more than 85,000 colonies. We used EMS, UV and DES as a mutagens, and two fungi which we used was Penicillium and Trichoderma ricci. Yeah, so these are like some studies where we found that if it is if it produces at least 25% or 30% more than the parent organism, then only it is getting selected. We have few patents on this, like based on the selection method also. So here you can see there is a zone. This is amorphous cellulose plate, and based on the size of the zone, it is being selected. Sorry, here you can see that the zone is quite big. So JP11 is one of the potent mutant. And here also you can see the size of here the best thing was the size of the colony is small, and then the zone is quite big. So that is very important. Here if we see the microscopic view, then we can see that the mutant are more smaller with more apex. So the enzymes are being released from the apical region. So that is the reason that production has been increased. And one most important quality was when we see that while fermentation, the parent is more viscous, whereas the mutant is less viscous, and it is producing even higher. So that is a very, very important quality, or we say property or characteristic, which we should take care while going for high scale production. Why? Because in high scale production, then the viscosity is a big issue. So that can be that this is more homogeneous, and it will help a lot for the scale up of the process. And here, yeah, this is like some of the productivity. We were getting increase in the productivity with the mutants. This mutant is higher than the parent. We can see 3.66, and whereas it has been increased to 8, that means twofold increase is there from 5.4, and then the mutant is having 7. So that kind of increment. Here we set up a benchmark for our enzyme, which has been produced by comparing them with the commercial enzymes. So these two enzymes, CTEC3, CTEC2 and CTEC3, these are from the Novozymes, whereas this is advanced enzyme. I talked about Saccharicep, and these are our in-house produced enzyme. So after producing, we set a benchmark, and we knew that we are still far behind than what is available in the commercial market. So we have to move forward for further improvement. This is the facility that we use. There are several reactors, small scale and up to 7 liters, up to 14 liters, sorry. This is, I think, 3 liters, and then 7 liters, and then 15 liters here. We used several strategies to increase the production, like mycelium inoculum instead of spores, then fed batch process, and then we changed impellers because we were facing a lot of difficulties for maintaining the dissolved oxygen, which is very necessary for aerobic process. And then we also tried to do pH shift strategy, which was useful also. So several things we followed to see if we can increase the productivity. And yeah, this is like, I have just included few slides of my work because it was said that students may not be interested to see all the data. Yeah, so here it is like a typical data for production of cellulase from Penicillium enzyme, where we can see that what is the relation with the biomass and then the cellulases. So if we can see, we can see that this is PCV is packed cell volume. When the biomass of the fungi, it keeps on increasing till 48 hours, and then it gets decreased. Why? Because the cell starts dissolving. And then the cellulase keeps on increasing. Cellulase production, it keeps on increasing, and we can get maximum at 96 hours. So that is really good. Here we also try to use both the enzymes RC23-1 and MRJ16, like penicillium, from Penicillium mutant as well as from Trichoderma ricci mutant. we have tested both the enzymes, and we found that the hydrolysis by using penicillium enzyme was higher comparative to the one with trichodermatoses. It is giving like 60% of maximum hydrolysis with 10 FPU, whereas it is very high. It is more than 70% with the 10 FPU. Yeah, here 72% using 10 FPU. So what could be the reason for that is the high production of BGL. Okay, so here we also try to see the cellulases which we have produced is resistant for the inhibitors which is being produced, so that during the pre-treatment, whatever inhibitors are released, we just don't need to have a washing step with that. We can just immediately we can use that for the hydrolysis, and maybe can be used as a medium for the cellulase production, so that we don't need to wash it or throw it, or we don't need to waste that liquid. We can use it for preparation of our medium. So we found that yes, our cellulases are quite resistant to that. Even it gives production, even it hydrolyzes. It is not an issue. So here also we try to overcome like what to say, if we can just bypass the purification step. So for that, what we did was we tried to use the mycelia also for the cellulase, for the hydrolysis, and we found that even the mycelia itself can give a better hydrolysis just as the enzyme. That means that mycelia itself can act as a source of enzyme. Then why to remove mycelia from the enzyme source? We can use the whole broth as such as a source of cellulase. It will again decrease the cost of our technology. So yeah, we have worked on solid state fermentation also, where also we were able to demonstrate that we can bypass this extraction method, and we can bypass this purification method. We can use this solid state fermented matter itself as a source of enzyme. We can just mix with buffer and some pre-treated biomass, and then it is also getting hydrolyzed properly to give us sugars which can be further converted into ethanol. So this is just to summarize bioprocess for cellulase production from fungi. Like this is a process which we have set up in our lab. We use spores as inoculum. This is the number of spores. Then we grow it into small vials, and then when PCV reach to 40%, we transfer it into the medium. We monitor daily like PCV. In few hours, we have to monitor this packed cell volume, that is biomass, then pH, ammonical nitrogen, then activity of the enzyme, then protein, and dissolved oxygen has to be maintained at 30%. However, during the very high growth phase, it is not possible to maintain that, but it doesn't matter. So temperature was maintained at 30 degrees centigrade, and we could harvest it at 96 hours. Yeah, so thank you so much. I hope that I was able to deliver a few things to the audience, which is important for them. So yeah, here I would like to acknowledge organizers of the webinar, St. Francis de Sales College, for inviting me to deliver the lecture, and of course, my previous institutes where I worked, and my colleagues, my students, and National Kaohsiung University of Science and Technology, Taiwan, where I am working now, my family. Yeah. Thank you so much. And here is my email address given here. If you find anything, after now I can answer your queries, but if you have any question, you can always contact me through these emails. And yeah, I would like to also say that we have few PhD positions here, and if there are some master students who are really willing to do doctoral studies in bioprocess, they are welcome to contact me. We have applications out, and thank you so much for inviting me and giving me opportunity to speak with all of you. I will be happy to answer a few queries if anybody is having. Yeah.
Thank you, Dr. Reeta, for your your nice presentation. It was really very engaging, and I think by any measure you are indeed a very effective speaker and educator. You have
Thank you.
explained very nicely about biorefinery steps of production of ethanol, pre-treatment of cellulases, and production of cellulase enzyme as well. And I think the topic was very timely, and it was presented very in a very good manner. There are few questions for you. May I put them forward?
Yeah, please. Yeah.
Dr. Reeta, in India, a lot of biomass is wasted by burning in fields. So, if they go in production of this, I think we may solve two problems with a single solution. So, what are the minimum requirements for production of bioethanol from this biomass? So, is there any
Yeah.
technology available in India wherein a farmer can go in for setting up own venture?
See, Sarika, this is really an interesting subject which we are striving towards. Like, we are seeing that a lot of biomass is being burned in the fields,
Yeah,
which should
especially
not be.
in the
And
north,
yes, and
problem.
I have stayed there in Faridabad for more than 7 years, and I found that during Diwali season there is like a big smog in the sky, and it's difficult even to inhale air. So that was. But then one thing has to be understood that poor farmers, or even not the poor farmers, the big farmers, to take after ripening the ripening of their agricultural products, rice or wheat, and if they remove that, and to get the lower portion which is left, like this portion is left in the land, and they burn it. And if they want to remove it, definitely it will give we can convert it into bioethanol. That is, there is a technology, but then to remove that from the field is a big challenge, because it is like we have to understand these biomass are very, very lightweight. So it will be like if you are selling it 2 rupees per kg. So the charges of the labor is very high there if they want to remove it. So what we have to do is, I always, we have these discussions everywhere, and I feel that government only can take initiatives to remove these from the land and get it, logistic has to be prepared, that they have to be transported to the place where bioethanol is being produced. It is not possible for farmers to have to set up the bioethanol plant or do that, because it is not feasible. However, that biomass can be definitely used for adding more value, but then they have to be removed from the field without burning. And definitely they have a purpose, that they are burning it to supply carbon to the land also, I heard in the discussion. However, I do not have much knowledge on that. Yeah, maybe Professor Kuldeep want to say something?
Yeah, Dr. Reeta, I was so happy to listen all your talks, and it's very, very important relevance to our country, particularly the Punjab and Haryana you were talking about. But there is always a problem, and the problem is that we say that the government has to take up all these things. This is the only problem in our country, that government never starts.
Yes.
That is the problem. Otherwise, there's no problem of this air pollution and all other things which happen in Delhi during the particular months when they burn this palali and other things in their fields. So one point I want to make it very clear to all my younger lot, that we have to create awareness, and we have to motivate our MLA, MPs, and all other things, then they should take it on the part of the government. Government should take initiative. Only then we can solve the problem. Like my own talk, I am going to talk today about biodiversity and conservation. Until and unless government will take initiatives, people cannot take initiative to a greater extent. So I'm so happy that you spoke like this, and you are still having a thing in your mind that probably government agencies should come forward and sincerely and honestly, if they work, we can solve over this recurring problem in our country. But I just want to say this. think Dr. Sarika, time is because I have another assignment, and we should thank Dr. Reeta, and I should allow me to start.
Yes, sir, definitely. Thank you very much, sir, and thank you, Reeta. I hope I am audible.
Yes, ma'am.
Yes,
Dr. Reeta, your mic is off. Please switch on your mic, please.
I'm very sorry. I'm very sorry.
Thank you.
I was talking. Okay. Sir, Kuldeep sir, just give me a few minutes. I also wanted to add, like, now, you know, to do this waste treatment and everything, now government, instead of government, there are many private firms which are coming up, and they have really good technologies. What I have heard, like several conferences I have attended, and like Dr. Vivek Agrawal is there, whom I heard, and he is having something in Jaipur. So what I'm thinking is, it's like it's the time that we move forward, just not depending on the government, and then we have to have our own technologies, because this environment belongs to all of us. We don't have to wait for the government. But I agree that yes, government has to take initiative to remove the feedstock from the land, or otherwise, if a private company is being set up, they can do it for their for their profit, definitely, because they are profit motive companies and they cannot just work for the sake of this thing. But yes, thank you so much, sir, and I'm very sorry for little bit taking more time. However, I'm very much particular about the time, but I didn't see. Yeah, sorry.
That's wonderful.
Reeta, one last question. Can you name few institutes in India which are currently working on this particular area, especially bioethanol production or cellulase?
Yes, definitely. Lot of see where I have worked, National Institute for Interdisciplinary Science and Technology, Dr. Rajesh Sukumaran, and it was started by Professor Ashok Pandey, who is the top biotechnologist in our country. See, he has got a lot of name and fame outside and in India also. And then now Rajesh Sukumaran, Dr. Rajesh Sukumaran is there, who is my supervisor, who was my supervisor also. And then Dr. Binod is working. And there are other institutes, like in IOCL, it is being worked in IACT, UICT in Mumbai. It is like bioethanol they are working on. And I think they are the major ones where work is going on, because DBT has installed 5 centers, right, for bioenergy especially, and that was in IOCL where we worked, and in UICT Mumbai, and then few IITs were also involved. Okay, thank you so much. I can answer all the questions through my email, because Professor Kuldeep will be very happy otherwise. I can understand. So thank you.
Thank you very much, Reeta, for answering
Thank you.
queries with ease and expertise. I am confident that all our participants must have got benefited with this session. Thank you once again for a very valuable experience. Now I hand over the proceedings to Mrs. Sonika Hilson, faculty from Junior College Biology Department. Over to you, Sonika.
Thank you, Dr. Sarika. Yeah. Once again, a very good afternoon to everyone present with us today. Moving into our second session, on behalf of the management and principal, Dr. K.T. Thomas of St. Francis de Sales College, Nagpur, I would like to welcome our second guest speaker of the day, Dr. Kuldeep Krishna Sharma. Dr. Sharma is a superannuated professor from Jammu University. Sir has portrayed various positions of a lecturer, a reader, a professor, head of the department, dean at the Jammu University. With a rich experience of 38 years in research and teaching, age is practically just a number for our eminent guest. He still continues to work very closely with the education industry. Currently, Sir is the chairman of the Ethical Committee, IIT Jammu, the Ethical Committee, Government Medical College, ACMOS, the chairman of Himalayan Conservation and Research Foundation. He is an adjunct professor at DAV University Jalandhar and also at the Central University of Jammu. Dr. Sharma has been a member of various prestigious academic bodies. He has received many prestigious awards and fellowships like this, he has been selected as a young scientist by the Department of Science and Technology, Government of India. He has been selected for Indo-Russian Scientific Cultural Exchange Program by UGC. Sir has been awarded gold medal by the Academy of Environmental Sciences, India. He has also been awarded a gold medal by the Zoological Society of India, awarded fellowship by Zoological Society of India, and the list is endless. Sir has completed 35 research projects at the national and international and also at the university levels. Dr. Sharma has 136 research papers published in national and international journals to his credit. Sir has supervised 29 PhD theses and 21 MPhil dissertations successfully. He is a member of more than 20 esteemed and learned societies. Sir has attended innumerable seminars and conferences and successfully organized and coordinated innumerable seminars and conferences. We are indeed fortunate to have such a magnanimous personality with us with such a robust and elaborate experience. It is indeed going to be a wonderful session full of learning and evolving. I now humbly request Dr. Sharma to take over today's session. Over to you, sir.
Thank you very much, Professor. I don't think that I deserve so much appreciation and other things. But, at the fag end of our career, these things are added because of the hard labor and sincerity in the work. I tell you very frankly. Now, as for the talk of today's lecture, when Dr. Sarika contacted me, I was so happy to share some of my view about some aspects of biodiversity. As you know, as the Principal Nikhil talked about, the unjustifiable as well as the merciless usage of the natural resources, which the people have used and created a lot of loss to the diversity of various animals as well as the plants. Under the pandemic conditions we have observed in 2 years, and these are our personal observations also, that when the lockdown was there, when the people were not allowed to go to the anywhere, they were kept inside. There is a ray of hope I see that it has improved the situation of biodiversity at various places in the aquatic ecosystems, in the terrestrial ecosystems, in the forest ecosystem. That is well under regards. But if you look at the challenges are many, many. And as rightly said by Professor Nikhil, that use of R is very, very important. The various R's is very, very important. Green building concept, uses of the solar energy, are the different initiatives which has been taken by the present rulers in order to save the biodiversity. These initiatives have already taken by our younger lot. Younger people have taken the initiative and they have been able to conserve the biodiversity to some extent. Now, as the madam was talking about in the morning, and as we had a very, very illuminated lecture by Reeta madam about the biofuels and all that, the biofuels will only be possible if the biodiversity will be there. And if biodiversity will be, affected, or there will be a loss of biodiversity, then the production of biofuel maybe Hamford also. So very, very important here is that we should take very a serious view of the biodiversity in our country. As the principal madam talked about the degrees, the normal degrees which we get from the various institutions. So far as biodiversity studies are concerned, these degrees are not very, very important. As I can quote you one of the examples. Might have heard about those who are nature lovers and all that. Dr. Salim Ali. Dr. Salim Ali has done a lot of work, tremendous work on the biodiversity or the diversity of avifauna in the Indian subcontinent, particularly in the Himalayan regions. And if you look at the qualification of this man his qualification is, he was just a matriculate, developed a passion, started studying the wildlife, and ultimately come up with the exhaustive studies of the Indian birds in the Himalayan regions as well as in other subcontinent. I remember one of the incident when I was also there to attend the facilitation functions of Salim Ali. Our great Prime Minister Indira Gandhi was there. So Salim Ali, a simple man, was standing on the chairs, on the stairs. The Indira Gandhi passed from him and then went to the area where the function was to be organized along with his bodyguard and other things. But she asked, where is Dr. Salim Ali before the function? I just want to see him. Look at the simplicity of a man that the guard told her, sir, madam, she is standing. When you started rising the stairs, he was standing there. So such a simple man, she immediately come down and met her. Okay, Dr. Salim Ali, I bow my head before you that you have done so much of the work. So these are the things goes on. No, I'll take up my talk, some aspect of the biodiversity. May I have a first slide, please? May I have a slide? Next. Yes. Now, if you look at the biodiversity, when we talk about the biodiversity, the variety of life forms are there on the earth. And these forms, they have a lot of interactions. Actually, the biodiversity is the most complex, and it is very, very vital for the planet Earth, where a lot of organisms are there interacting with each other, plant interacting with animals, animal interacting with the plants, and vice versa. It's happening. What? If you look at, without it, there is no future for humanity. This has already been said by Professor David McDonald's of Oxford University, that if the wildlife, if the plant diversity, if the biodiversity is not there, there will be no future for the humanity. Humanity will also be in a trouble. If you look at scan the various literatures, you will find that the term biodiversity was first coined in 1985. And it is a contraction of biological diversity. But huge global diversity losses are there, and these are now becoming apparent and represents a crisis equally or quite possibly surpassing the climate changes. If you look at the present scenario, we talk about the more formally, we can say that biodiversity is comprised of several levels, many levels of the biodiversity, and starting with genes, then individual species, then communities of creatures, and finally the entire ecosystems. Then communities of the creatures, the final ecosystems such as the coral reefs, such as the forest ecosystem, where life interplays with the physical environment. That's very important. These myriad interactions have made Earth habitable for billions of the years. Next, a more philosophical way of viewing the biodiversity is this, that it represents the knowledge learned by evolving species over millions of the years. What we see today is an outcome of millions of the years about how to survive through the vastly varying environmental conditions, as we are talking about the climatic conditions nowadays. Earth has experienced, it is seen like that. Experts, they warn that humanity is currently burning the library of life. Next, please. Next slide, please. So if we look at, there is enormous varieties of animals in the nature, and they have interested modifications which they generally display. Apart from the animals, plants are there, but I'll be restricting some about the animals. Next, please. Now, look at the picture. If you look at this particular picture, you will find that the fishes, which are aquatic animals, lives on the oceans, lives on the fresh waters, lives on the lakes and others, have a very type of the habitats in which they live. We have shown the diversity. Fishes, they have terminal mouth. They have terminal mouth. They have terminal mouths located at the terminal, and are subterminal mouth below the terminal, and are mouth facing towards the dorsal side. Next, please. Next, please. Next slide, please. Yes. Now, some of the fishes are deep sea fishes. Now, deep sea fishes are having very unique characteristic features. Their eyes are also very much reduced, and they have a specific type are not there, and they don't move much, and their fins are also modified. Next, please. Next slide, please. Yes. So there are some of the fishes. I'm talking about the various diversity among the fishes. And one of the type of fishes, we say that they are the blind fishes. They live in a caves where the light is not there. So their eyes are not fully developed, and they have sensation to go ahead, move here and there and catch their prey. These are called as blind cave fishes. Next, please. Yeah, majority of the fishes living, we have different type of the fishes where the streams are very fast, and in order to stick to the streams, they have developed these photographs. And then if you look at the position of the mouth, their position of the mouth is always on the dorsal sides, subterminal mouth, because they have to scratch the stones to catch the food and to survive themselves. So some of the modification of the food in the hill streams fishes is well marked in this particular slides. Next, please. Next, please. Yeah. Some of the fishes living in Antarctica we talk about, where snow is always there. They are the Arctic fishes. Can you imagine that in the snow? water, fishes are living. Lot of decline in the temperature is there. Temperature is very, very less, even 0 degrees centigrade, and they survive. What are the mechanisms? These fishes, they have developed a anti-freezing proteins, which keeps their fluid always in a flowing conditions inside the body of these fishes, and that's why they survive in those areas. Otherwise, if their blood and other fluid is, also with the low temperature freezes, the fish cannot live there. So it is living there with having anti-freeze proteins. Next, please. Next slide, please. Yes. Now look at, there is a diverse variety of insects we see here and there moving. We have the mosquitoes, we have the night insects, cockroaches, we have the flies, we have the bees, we have many types of the insects which play a vital role in doing a lot of things for the mankind or for the benefit of the mankind. Now, if you look at the legs of these insects, they are highly modified and highly diversified. One of the type is where cursorial type of legs are there. These legs are for walking and running. Examples are are the ground beetles as well as cockroaches. These types of legs. Next, please. Next, please. Yes. Then the another type of insects which are having fossorial legs. The front legs, they are for the digging of the soil. And examples, as we see, the mole cricket is one of the classic example of these, the fossorial legs. Next, please. Next, please. Yes, we know. We have all seen this particular insect is a praying mantis. This insect is having repetorial legs. The four legs are adapted for catching the prey. That's why it is called as a, the praying mantis, and four legs are very strong, help in catching the prey from the different types of the environments. Next, please. Next slide. Next slide. Next slide, ma'am. Yes, the Celtorial eggs. These are also important types of the eggs. Particularly, we have seen some of the dacids, some of the grasshoppers, where their hind legs are for jumping purposes. The femur is very large in such type of insects, and they jump from one place to the other place by these strong legs. Next, please. Yes, we have already talked about the fossorial legs. Next, please. Next, please. Yes. Then natatorial legs. These are for the swimming, particularly the aquatic insects. They have to swim in the water. And for swimming, they have the legs with the hairs. And these are very prominent in case of the water beetles. Next, please. Then I told you these insects, they play a vital role in pollinating, in taking the pollens from one place to the other place, and then helping the biodiversity to continue, helping the plant diversity to continue, and the germination of plants and continuity of the plant diversity. Tibia in such honeybees are very, very strong, and there are pollen baskets attached to the tibia, and they take away these pollens from one plant to the other flowers, where pollens are dropped and the reproduction takes place, and new seed germination is there in case of the plants. So pollination is one of the important aspects, and probably the insects or honeybees are very, very important pollinators we have seen in our system. Can you imagine that if such insects will not be there, can you think of that our plant diversity will be there? our plants will be survived. This is going to be a challenge to the mankind. Next, please. Yes. We have seen that the scales are generally the characteristic feature of the fishes. And fishes, they are having scales. But look at the diversity. One of the mammoth, pangolin is there, which are having hard keratin scales to avoid the predators or to live for a longer life. Next. Yeah. This is one of the example of an amphibian that is called as a purple frog. So this frog very recently has been noticed. Look at the biodiversity. Look at the beauty of the diversity that this frog was reported in 2003, very recently in Kerala. And they say that once in a century, this particular frog appears. It stays underground and appears on second to third weeks in the monsoon seasons for mating purposes. This is a very predominant, particularly in the Western Ghats. Next, please. Another interesting animal, which we have recorded here, the photographs you see, having the long antennas, just like our Wi-Fi systems. They are the long-horned weaver, usual animals, unusual animals. They have unusual length of their horns, the antennas, about 45 millimeter in long, and the homologous horns of the Macracantha acrita is the animals. It makes the insect look like gadgets. And if the purpose of these horns or the bristles is not yet known properly, but some of the workers of the opinion that they may serve the purpose of intimidatory predators, helping in locating the predators and other things. Next, please. Another example which I have taken just to show the diversity, if you look at, looks like zebra, but this is not a zebra, it is octopi. It's a beautiful animals resembling zebras and also more like giraffes. If you look at the upper parts, tongue, the neck and others look like more than the giraffes. This is the only animal of the giraffe family, like giraffe, and they are also extremely very, very attentive animals, large upright ears, a long tongue they are having, and the hind as well as front legs, they are striped black and white like the zebras. Next, please. Then another aquatic animals, some of our friends or younger generation may be familiar with, might have heard about these stories of gharials. These gharials, मगरमच्छ जिसको हम कहते हैं, पानी में होता है ये. It is found in the water. This is a skinny predator. It's a predator, very endangered species, and found only in few of the rivers in Nepal as well as in North Indian rivers. This is one of the heaviest reptiles on the earth, and it is generally having a long protrude, front portion of the mouth, and this is having a 106 to 110 needle-like teeth that interlocks on snapping, and then it catches hold the prey in these and never allow the prey to go ahead. Next, please. Now, this is something I discussed with you about the diverse nature of the animals, some of the animals which are prevalent here. Now, we have a question. we always question a thing, and that is, do animals and bugs really matter to the mankind? When we talk about the biodiversity, we say that really these are mattering to mankind. For people living in a town, if you look at, or in cities, for them the wildlife is just like living animals, and they generally see this wildlife only on the television. But in reality, when we talk about the water we drink, the air we breathe, and the food we eat, ultimately depends on what? It all depends upon the biodiversity. So biodiversity is nothing but it is a mixture. It is a combination of all these things. And as some examples are very clear when we talk about without plants, if the plants will not be there, if the vegetation we will generally see that there will be no oxygen. There will be no oxygen on the earth. Just a minute, the slide is not. Yeah, there will be no oxygen on the earth. And I was talking about the pollination. Without the pollination, if there will be no pollination, if there will be no carriers, these insects and birds and other animals which help in pollination, there will be no fruit, no nuts, and no other things which is related with the systems. No, some of the examples, some of the other examples in this regards are, we have seen the coral reefs in the sea and the mangrove swamps. These provided invaluable protections from the cyclones and tsunamis for the coastal areas, and trees which are present all over the terrestrial areas, they absorb air pollutions in the urban areas. In the next, please. Next slide, please. Yes. Now, if we look at in each ecosystem, we find countless such interactions, all honed by millions of the years of evolution. If undamaged, it produces finally balanced, healthy system, which contributes to the healthy, sustainable planets. And more unfortunately, our biodiversity, as we generally talk about, the more formally we can say here that formally the biodiversity is comprised of several levels, starting from genes, then individual species, then communities of creatures, and finally the entire ecosystems, such as forest, coral reefs, where life interplays with the physical environment, and these myriad interactions have made Earth habitable for billions of the years they are living there. Then a more philosophical way of viewing biodiversity is this: it represents the knowledge learned by evolving species over millions of the years and how to survive through the vast varying environmental conditions, such as experience seen like that. Experts, they warn, humanity is currently burning the library of life. Then we come down to a mind-boggling question. How diverse is the biodiversity? When we talk about the biodiversity, is a diverse and a simple aspect to consider is the species. We generally talk about that the simplest aspect in biodiversity is to consider the species. And about 1.7 million species of the animal, plants, and fungi are there. One thing I would like to make it very clear to you that the new researches which are coming on, whenever we are exploring the newer areas, more species are entering into this arena. That there are many species which are unexplored even today. But likely it is to be 8 to 9 million and possibly up to 100 millions. The heartland of biodiversity is the tropics, which teems with species of different natures in 15 hectares. That is roughly about 37 acres of Borino forests. There are roughly about 700 species of the tree, the same number of the whole of North America. Next, please. Next, please. Now, if you look at the recent working considering diversity at the genetic level, is generally indicated that the creatures thought to be a single species when we talk about, and this single species could in some cases actually be dozens. Then add in bacteria and viruses, and the number of distinct organisms may well be in billions. And if you take a spoonful of soil, ultimately it may provide 90% of all foods containing 10,000 to 50,000 different types of the bacteria. The concern is that many species are being lost before we are even aware of them or the role they play in the cycle of life. Next, please. Then how bad it is, or when we say that how bad is it? It is very bad. Large mammals, best studies are the large mammals like the tiger number, if we look at, for example, have plunged by 97% in the last century. In many places, bigger animals have already been wiped out by the humans who are responsible for creating these catastrophe among the animals. Think of dodos and woolly mammoth, which are big ones, and they are facing extinction. The extinction rate of species is now thought to be roughly about 1,000 times higher. In the present scenario, it is 1,000 times higher than before the human dominated the planets. Can you imagine that how these anthropogenic influences has created a loss to the biodiversity, which may be even faster than the losses after a giant meteorite wiped out the dinosaurs, that is 65 years ago. And the sixth mass extinction in geological history has already begun, according to some of the scientists. They say that there were dinosaurs which were leading or having abundantly found on this earth was wiped out due to the giant meteorites are creating conditions of cold in our country 65 million years ago. They say that another extinction, that is the sixth mass extinction, has already begun in, and it is a matter of concern for all the scientists. No, lack of data means red list produced by the International Union for Conservation of Nature has only assessed 5% of the known species, but the rest of the species, known groups, it may find many are threatened, 25% of the mammals, 41% of the amphibians, and 13% of the birds. So species extinction, when we talk about, provides a clear but a narrow window on the destruction of biodiversity. It is the disappearance of large number of groups that is by definition are rare. But new studies are examining the drop in the animals, in the number of animals capturing the plight of world's most common creatures. The results are very scary if you look at. Billions of individual populations have been lost all over the planet, with the number of animals living on the earth have plunged by half since 1970, abandoning the normally sober tone of scientific papers. Researcher calls the massive loss of wildlife a biological annihilation, representing a frightening assault on the foundations of the human civilizations. Next, please. What about the undersea? What is the condition of these animals? If you look at under the sea, the humans lack gills. What that has not protected even the marine animals. As you know, marine animals, they are generally having a gills, and humans are not having a gills. And we see that the human beings are suffering because of the pollution, because of many things. But those animals which are having gills, even in a marine ecosystems, are not spared because of the pollution and because of the many things. They are also affected greatly. And situation is no better, even less understood by the various workers. Seafood is a critical source of proteins, and this is most liked by the people for the proteins for more than 2.5 billion people. What the rampant overfishing has in 1996 and now more than help the oceans in industrialized fishing. So this the rampant fishing for the want of the proteins has already created loss to the aquatic biodiversity, particularly in the aquatic systems. Next, please. No, what about the bugs? We generally talk about, do not cockroaches survive anything? No, these bugs, cockroaches, and other things are also important part of the niche ecosystem. The diversity is also very important. More than 90% of the known species lack a backbone. And there are about as many as species in the Staphyloaridae families of beetles alone as there are total vertebrates, such as mammals, fish, and birds. Altogether, there are at least 1 million species of the insects and about 3 lakh spiders, mollusks, and crustaceans which are available. But if you look at the recent reports, which are available with us by the various agencies which are working on the biodiversity and diversity of animals, that 75% of the flying insects were lost in the last 25 years in Germany, which is a matter of concern, and likely elsewhere indicates the massacre of biodiversity is not sparing even the creepy crawleries or crawling animals. Also, insects really matter, not just as pollinators, but as a predator of pests, decomposer of waste, and crucially, as the base of many wild food chains and support ecosystem. And if we lose the insect, then everything is going to collapse. This is finally understood by the world, and Professor Dhabe Golsons of Sussex University, UK, has already made this statement and professed that We are currently on the course of ecological emigrations. That is, we are leading a war to the destruction of mankind by eliminating these much required biodiversity of the animals. Next, please. Now, the next important point which I would like to mention here is what is destroying the biodiversity. If we look at there are many factors which are responsible for creating the disturbances in the distribution of animals and the plants. And one of the important logic behind this is that population of the human being is rising, and the wild areas are raised to make farmlands, housing, and industrial sites. So population explosion is one of the important factors which has created a problem in destroying the biodiversity. We are particularly, as the human population is rising, wild areas are raised to make housing, to make farmlands, to make more industries, and creating niches for the developing population. Consequently, the felling of forest is often the first step, and 30 million hectares of the forest, the area is Britain and Ireland, were lost globally in 2016. Poaching and unsustainable hunting is also one of the important aspects associated with the loss in the biodiversity. For the food is a major factor, and more than 300 mammal species, from chimpanzees to hippos to bat, are being eaten into extinction. Another factor responsible for this is the pollution, which we say is a killer too. The orcas, the dolphins are seriously harmed by long-lived industrial pollutants. The global trade contributes further harms. Amphibians have suffered one of the greatest decline of all animals due to the fungal diseases thought to be spread around the world by the pet trades. Global shipping has also spread highly damaged invasive species from the planet, particularly the rats. And the hardest hit, if you look at of all habitats, maybe rivers, maybe lakes, with freshwater animal populations in these collapsing. Roughly about one of the estimate is 85% since 1970, following huge water extraction for farms and people, plus pollution as well as for the dams. The another interesting question, which is generally asked, could the loss of biodiversity be greater threat to the humanity than the climate change? People are thinking on this. People are having diverse view on this. But the general answer is given is the yes. This is the general answer. Nothing on the earth, if you look at, is experience more dramatic change at the hands of human activities. Anthropogenic pressure I'm talking about. Change to the climate are reversible, even if takes centuries or millennia. But species become extinct, particularly those unknown to the science, there is no going back because you cannot have those species again. Though no doubt the climatic changes are there, they are prevalent, but once species is lost, cannot be recreated. At the moment, we do not know how much biodiversity and the planet can lose without promoting widespread ecological collapse. But one approach has assessed so-called planetary boundaries are there, which is a threshold in Earth's system and define a safe operating space for humanities. One of 9 considered just biodiversity laws, and nitrogen pollutions are estimated to have been crossed, unlike carbon dioxide level, freshwater used, and ozone losses. Next, please. Next slide, please. May I have the next slide?
Yes, sir. Just a minute.
Next slide, please.
So there seems to be a technical issue. Please give me a few seconds. I'll just get back to you. I'll continue with the slide presentation, sir. Please.
Should I continue I have the slides with me.
Sir, actually there has been some technical issue with Dr. Sarika. Then she has given the presentation to Sonika also, so she is presenting from her device. No issue, sir. Just give us 2 seconds, huh? We are joining.
It was going so normal and all. Yes, it's coming. It's coming. Yes. Yes, thank you. Now, the another important question is that what can be done? What we can do under these situations which are quite scary? And already the loss of biodiversity is there, which is well on record. And one of the methods to come on to this problem and come out of this problem is giving nature the space and protection it needs is the only answer for this particular questions. That there should be a will, we should give the nature a space and the protections by the way of government laws and other things, which is a need of the hours. As I told you in the beginning, and Madam Principal Nikhitji has already talked about that probably during pandemic period when there was no movement was very less and even negligible. We have seen in some of the areas the biodiversity has increased tremendously. In 6 months, we have seen a drastic changes. So that's why I want to emphasize here is that if we give the nature the space and productions, condition can be better to a greater extent. And wildlife reserves are the obvious solutions. If we create more and more areas where the human interference is restricted, we can do wonders. Wildlife reserves are the solutions, as I told you, and the world currently protects 15% of the lands, if you look at the records, and 7% of the oceans. What some argues that half the land surface must be set aside for the natures. So we have to increase our targets so that we can save the nature or the natural resources to a greater extent. However, the human population is rising and the wildlife reserve, if you look at, do not work if they hinder local people making a living. The poaching crisis for elephants and rhinos in Africa is one of the extreme example, making the animals worth more alive than the dead is the key. For example, by supporting tourism or compensating farmers by livestock killing by the wild predators, what it can lead to tough choices. Now, what are those choices? Look at trophy hunting for a big game is an anathema for many. What if the shoots are done sustainably, only killing old lions, for example, and the money raised protects a large swath of land? Should it be permitted? It's a question mark to us. That's very important. We can all help. Most wildlife is destroyed, the land being cleared for cattle, soya, palm oils, timbers, and leathers. Most of us consume these products every day, with palm oil being found in many foods and toiletries. Choosing only sustainable options when we talk about helps, as does eating less meat, particularly the beef, which has an outsized environmental footprint. The another approach which we generally think, and as has been highlighted, the value of biodiversity. By estimating the financial value of the ecosystem services which provide as natural capitals, and sometimes this can lead to real saving. Over the last 20 years, if we look at the data, one of the classic example which has been given is New York has spent, New York City in America has spent $2 billion protecting the natural watershed that supplies the city with clean water. It has worked so well that 90% of the water needed needed no further filtering, building a water treatment plants. Instead, we have a cost of $10 billion. So what I mean to here is a sort of good comparison that if we save the natural resources, we have not to, we are talking about the mineral waters and other things. And we say that if you go to the Himalayan area where the springs are there, if you take the direct water from those Himalayan areas, you will find that there is no need of having a filtration plant, a treatment plant, and spending money on this. If you conserve those resources, we can have a lot of advantage, and we can conserve the biodiversity to a greater extent. Next slide, please. What next? So this is an important option with us, that what next? What we do. Will. I'm talking about that it is a political will. It's the will of the government. Convention on Biodiversity set many targets, and some are likely to be reached. That is 70% of the all land and 10% of the oceans are to be tackled to save biodiversity by 2020. Others, making all fishing sustainable by the same data, are not there. As I told you, that fishing is also one of the aspects. Overfishing has already destroyed the great economy of the system, and has already affected the wealth of the ecosystem to a greater extent, marine ecosystem to a greater extent. Now, in 1985, Professor E.O. Williams concluded that this being the only living world, we are ever likely to know, let us join and make the most of it. That call is more urgent than ever. Next, please. Next slide, please. Next slide, please. Now, if you look at the slide, I have marked, this is the picture of some wildlife things which are prevalent, and the World Wildlife Researcher in 1900 and in 2014, very recently, they projected some data. Next, please. Next slide, please. They projected some data, and as per the reports, they say that between 1970 and 2010, next please, in just 40 years, next please, the population of the wildlife vertebrate decreased by 52%. Imagine that in a gap of this 52% vertebrates, they have been eliminated. Wild vertebrates have been eliminated from this earth, which is a matter of great concern. Next, please. Then after 2 years, they released another report. That is the second report. And in second report, next please, they said that between 70 to 2012, that is 2 years after, 10 to 12, 2012, next please, this decrease in the population of wild vertebrate has enhanced to 58%, 52 to 58% in 2 years. Such a drastic change was there. Such a pressure on the part of the various animals was there. Such a destruction of the biodiversity was there. Next, please. So these two data points, what these data points? Next, please. You can perform a simple mathematical calculation to tell you, we have done the mathematical calculation, and according to mathematical calculations, next please, by 2026, next please, next slide, yes, that at the rate, if the rate of decline continue like this, by 2026, there will be no wildlife available to us, or the wild vertebrate will be available to us. Next, please. Next, please. Yes. So 100% of the wild vertebrates will be gone by 2026. So this is a simple mathematical calculation which we devised and calculated, and the rate at which from 10 to 12, the destruction of the wildlife or destruction of the wild vertebrate took place. We simply gave a mathematical calculation, and by that rate, when we calculated, we found that by 2026, there will be no wild vertebrates, and there will be a 0 year. That will be called as a 0 years, when wild vertebrates or wild animals will not be there on this universe. Next, please. And this will be called as a 0 years, as I told you. No animal will be there. Very rarely you see a wild animal, as in picture. We have shown the one of the elephant is there. Next. The year when all the wildlife animals are gone, next. It turns is not only, next please, the number one source of carbon emissions. This animal is a source of carbon emission, that it is not only the carbon emissions. Next, please. It is also the number one source of land use on the planets. When we use these animals, they are very, very important. These vertebrates are one of the land use of the planets. Next. All over the world, humans are destroying the original forest. As you know, the forest fires are there. These nomadic peoples, when they go to the forest, they generally lit the forest fire, destroy the forest, the wildlife habitat is destroyed, and they have agreed for this fire is that when next year they will come to the upper reaches, that reaches with the ashes and other things will generate more of the grass for their livestock. This is one of the reasons that they start destroying the forests, these nomadic and the Gujar peoples. The intention is to get more feed for their livestock, but in turn, they destroy the forest, they destroy the wildlife habitats in the forest area, thus affecting the biodiversity to a greater extent. Next, please. Then, to make room for the grazing animals, what we started to cultivating the lands. Next, please. With the help of the, we started growing the crops for feeding the animals at the downhills. Next. And then in the oceans, the humans are using sophisticated geolocating technologies for catching the fishes and other organisms from the sea. Next, please. To locate the last remaining schools of the fishes. So ruthlessly, without mercilessly, we try to use various technologies, and by those technologies, we are catching more and more shoals of the fishes from the sea, and that's destroying the wealth of the sea to a greater extent, or the biodiversity of the sea to a greater extent. Next. Next, please. And finally, we are pouring all these toxins into the atmospheres. You know, we use a lot of pesticides, herbicides, and others into the atmospheres. Now, what it is creating, we are just saving our crops, but what loss it is creating to the creatures and other animals is of nobody's, problem. People are not thinking on these things also, and they are pouring toxins into the environment. Next, please. And these, toxins, they are killing insects. And I have already told you in the morning that how insects are very, very important as the diversity of insects is very important for the mankind. Next. And which kills the avifauna also, the birds also, that eats the insects. Next. So we are attacking the wild animals on the land by different ways. Next. In the ocean, as we are taking fishes from this pollution and other things are in the oceans are causing greater loss to the biodiversity. Next. And in the air, we are spraying the toxic elements into the atmosphere, pesticides and other things, destroying the terrestrial animals. Next. And this leaves wild animals no room to survive finally. Next. We did some calculation also regarding this. And next. We took all the land that is currently being used for the animal agriculture. Next. And restored the native forest that were there on the land in 1800. Next. And it turns out not only that you could sequester more carbon, because more and more forest grows in those areas where we experimentally did some experiments, and more carbon dioxide from the atmosphere was taken by these plants in the process of photosynthesis. And they grow like this, and they cleared the air also. make the air more clearer and purifier. Next. Then we have added to the atmosphere since 1750. Next. What? You also restore the natural habitat for wild animals to live. When the forests were restored, the natural habitat for the wild animals were created and they started living in those areas again. Next. It is their world. Yes, too. Forest is, this world is also for these animals also, not for the human being. We have to think very seriously on this point. Next. So this is entirely possible, as I told you. Next. We can bring back the forest and we can heal the climate. Next. And in the process, ensure that year zero never becomes a reality. This we have to keep in our mind, and the government organizations, they should also feel that year zero never becomes a reality, and only then the mankind can be saved and the biodiversity can be saved to a greater extent. Next. So year zero does not need to become a reality. This should be the slogan in all the coming days of the various countries. Next. Next, please. So thank you very much. I'm highly thankful to the principal ma'am, staff of the colleges, and particularly the Sarika ma'am, who gave me an opportunity to put forth some of the points which I thought of for today's presentations. I'm sorry that Sarika gave me a very, very little time when she contacted me, and whatever efforts I could put on in bringing things together and presents before you. I'm again thankful to the organizers for the time they have given me. Thank you very much.
Thank you, sir. It was indeed a treat to listen to you. The simplicity and ease with which you explained, I'm sure our participants have a lot of takeaway from it. You shared exuberantly from your in-depth knowledge, which speaks volumes about your pristine stature. You spoke so elaborately and so convincingly about the present scenario of our biodiversity, and I'm sure our participants, which includes a lot of students, undergraduate students, have learned and become more aware. It's very easy to look at our own gardens, the small gardens that each one has in their own houses, but when we talk about the world in which we live, it is really a long shot, and like you said, that it is achievable, it is attainable, and I'm sure our participants will become more aware. And so we understand you have a busy schedule, and we have exceeded your time limit as well. So we will be emailing you all the questions that our participants have put forward, and yeah, you can reply them.
Definitely. Yes. Thank you very much once again.
Thank you, sir. Thank you. It was a pleasure to have you. I would now like to take this opportunity to propose a formal vote of thanks.